So hello my dear students, I hope you all are doing fine. So I welcome you all to my 7th lesson of class 9 physical science, and I promise you this class is going to be very wonderful if you all pay attention to this class. Okay students, so let me start today's class by just showing you a picture, right? So can you see this picture students? Yes? Okay, so in this picture, students, we can see that different people are performing different type of exercise, isn't it? This person is standing, she is doing some type of asana, she is also doing some type of asana, right? So they are doing some exercise, and let's look at ourselves also. Like we got up early in the morning, had our breakfast or lunch or tea or snacks, whatever we eat in the morning. Then after our eating schedule, we finished packing up our bags and then came to the school, isn't it? When we came to the school, we did a lot of work, isn't it? We did a lot of work in coming to the school. Like someone cycled to the school, someone came by their feet, someone used bus, isn't it? So how do you think were you able to do so much of work? Students, yes, do you require something to do work? Yes, we require something, and that something is called as what? That something is energy. We require energy. Yes, right? So this is the topic of our today's class. We are going to study energy. Okay, students? Right. So now I'll give you two examples. Okay. So now tell me that when you will be able to do more work. First, when you are tired, or second, you are in a good mood, you are relaxed, you are fully energized. Yes, students? Right. So in the second case, that is when you are energized and you are in a good mood, you will be able to do more work, isn't it? Right. So students, how do we define energy in physics? We define energy as the capacity of doing work. Okay, students? So write down in your notebook. So energy is the capacity for doing work. Right, students? Okay. So ability to do work is also known as energy. Right, students? Yes. So work can be done only where there is energy. What I told? First of all, I told energy is the capacity of doing work. Second, I told ability to do work is also known as energy. And third point, I told without energy, there cannot be any work. Okay, students? Without energy, there will be no work. It can be understood by the example that I'm giving to you now. Suppose that if you are having a very bad day in the school, you are really exhausted, you are doing PT or you are doing march for all the 8 periods in the school, and then you got to the home and then again you are told that yes, you need to do this work now. So how will you feel? Will you be able to be like do this work? No, because then you will be feeling very tired. You will not be left with any energy. But then when your mom will offer you some type of drinks like cold drink or glucon D, then you will get energized. When you will eat food, you will get energized, and when you will get energy, then you will be able to again work. Right, students? So we can say that ability to do work is called as energy, and without energy there will be no work. Okay students, so we can say indirectly we can say that energy is equal to work. Right students, energy is equal to work. Now students, we will study about the unit of work. Okay students, so we know that the unit of work will be also the unit of energy, because energy is nothing but the capacity of doing work. Okay students, right. So we know that the work done can be represented by W equals to F times D, right? So W equals to FD. So we can say that 1 joule equals to 1 Newton into meter, or we can say 1 kg meter squared per second squared, right? So this is the equals to equivalent of 1 joule, right? So the SI unit of energy is also what? the SI unit of energy is joule. Understood, students? Right. So now let's go to the quiz section. Right? So the first question is, the ability to do work is known as what? The ability to do work is known as, yes, students? Yes, it is known as energy, right? The ability to do work is called as energy. And what is the SI unit of work done, students? The SI unit of work done is joule, right? It is also the SI unit of energy. So 1 joule is 1 Newton meter. Understood, students? Right. So now let's proceed ahead. Yes, students. So now, do you see this picture? Yes. Can you see this picture, students? Right. So in this picture, we can see that this child is trying to move this lawnmower, isn't it? So will he be able to do it? What do you think? Yes. Okay. He might be able to do it, isn't it? But not for a very long time. He might be able to push it like 2 centimeter, 3 centimeter, 4 centimeter, 1 meter, but not more than that because it's not having so much of energy. The lawnmower is very heavy. These children are also playing something, playing with some rubber balls or something. So, do you think that they will be also like play only play for a very long time, say 24 hours, 26 hours in a continuation? No, we cannot because we have a limit to it, right? So now let's take an example. Suppose that I will take you for a walk. Okay, students? I'll take you for a walk and I'll take you for a walk, but then what you have to do, you have to continuously walk with me, right? So do you think you will be able to walk continuously without taking any breaks or without like sitting anywhere or eating or doing anything? No. What you will feel tired. When we work continuously, we feel tired. But students, then the question arises, then how is the work being done? How does that object work? Isn't students? There has to be some relation between the work and energy. Right, students? There has to be some relation between the work done and energy. Yes, right. So students, we say that when the work is performed, energy changes from one form to the another, right? So suppose that this is a car, right? And this electrical energy is being converted into kinetic energy through this car, isn't it? We have seen Teslas. So in this car, what is happening? This car is using the energy from this battery and using it to move it, right? So similarly, we can have petrol car also. So petrol is storing chemical energy. So this car can use the chemical energy or convert the chemical energy of the petrol into the kinetic energy, isn't it? So we can also convert like chemical energy of the petrol or any natural gas into electricity that can be used to light our bulb, light our laptops, light our mobile phones, isn't it? We can use chemical power energy for mechanical purposes, like we can send rockets into space. We as a human, we eat food that is having also chemical energy. Then those chemical energy is being used by our different activities, like our kinetic energy. We are running somewhere, then it is being used as a kinetic energy. We are sitting, we are climbing on the top of somewhere, so we are using we are just increasing our potential energy then, right? So we say that when work is performed, energy changes from one form to another. Right, students? Okay. Whenever the work is performed, the energy changes from one form to another. Right? So as soon as the energy inside our body is getting finished, right, is getting over, so we start to feel tired. Okay, I don't want to do any work. So these type of activities occur when you have no energy left with you. Okay, students, shall we proceed ahead? Right. So students, just see it, what is happening. Here is a raised hammer and this hammer is falling on this nail. Okay, students, and this is a ball that is hitting the wicket. Yes, students, can you see this? Right. So tell me what is happening in these pictures. So students, we see that when a raised hammer is falling onto a nail, it is pushing the nail inside the object, isn't it? And when this ball is touching this stump, this ball has a kinetic energy, right? So, and this stump has a potential energy. It is just sitting there, right? So this ball changes what? This ball transfers its kinetic energy to these bales, and these bales fly off, right? Similarly, this hammer is having kinetic energy, and it is transferring its kinetic energy into nail that is driving it inside the object. So that is what is happening in this picture, isn't it? So what we can conclude from these pictures also, we can say that work is performed when energy changes from one form to another. Okay, students, we say that work is performed only when energy changes from one form to another. Right. So now let's proceed ahead for a quiz section. So students, can you read this quiz? Yes. So the question is, what is the relation between work and energy? Yes, what is the relation between work and energy? Right. So the relation between work and energy is that we can perform work only till when we have energy, right? So ability to do work is called as energy, right? And how the work is being performed? Yes, students, work is being performed when the energy changes from one state to another, means one form to another form, right? So suppose that there is electrical energy, and this electrical energy is converted into light energy by the means of bulb, right? So we say that work is being performed here. Okay, students, you ate a pizza. Suppose that you ate a pizza, right? And that is providing you energy to move, isn't it? That is providing you energy to move from here to here, right? So this is also the form of energy, and you do work only when you have energy, right? So now let's proceed ahead for our next video. So students, what can you see in this picture? Okay, so there are different types of energy, namely mechanical energy, thermal energy, nuclear energy, chemical energy, electromagnetic energy, sonic energy, gravitation energy, kinetic energy, potential energy, and a special type of energy that is known as atomic energy. Okay, students? Right. So mechanical energy is the energy by the property of its mechanics, right? Thermal energy is just the heat energy. Nuclear energy is the energy that we get from splitting of nucleus, right? Or we can say in the nuclear reaction. Chemical energy is obtained by chemical reactions. Electromagnetic energy is obtained by electromagnetic radiations. Sonic energy is the energy of sound. Gravitation energy is the energy produced by earth, right? It is the energy of the earth. Kinetic energy we will see in more details. We will see potential energy also in more details, right? So now we are going to study about this kinetic energy. Okay, students? Right. Now students, do you see this ball here? Yes. What it is doing? This ball is moving, isn't it? This ball is moving in this direction, right? Now suppose that here was a batsman, and this batsman hit this ball, so this ball is moving in this direction. So tell me, where does this ball gets its energy from? Yes, students? Right. So it got its energy from the batsman who struck it, isn't it? Right. Okay. So now, what would happen if the ball would not move? If the ball would not move, students, then the energy is being transferred to it, and so what it will be doing? It will convert into some another form of energy. Okay, students. So like that, we see that energy is being transformed from one form to another. So now, let's look at the kinetic energy. Okay, students. Right. So students, we know that kinetic energy of a body moving with a certain velocity is equal to the work done on it to make it acquire that velocity. Suppose that this is a mouse and it is at rest. Suppose that if I want to move this mouse, then what I have to do? I have to put in works so that it will start moving. So like I have to throw this mouse. So I have to use my hand to provide work to it so that it gets its kinetic energy to move forward. Right, students? So now let's derive an equation to see what is the formula for the kinetic energy. Right? We know from the equations of motion that v square equals to u square plus 2as. Right, students? So we can rearrange it as v square minus u square equals to 2as. So now it is just rearranging again. So v square minus u square by 2a. We can get this equation. Right. So from the equation of Newton's second law of motion, we know that force equals to mass times acceleration, and we can write that work done equals to mass times acceleration into what we have determined for as v square minus u square by 2a, right? Or we can say that work done equals to half into m v square minus u square by 2a. A is cancelled here, right? So it is half m v square minus u square, right? So if the body is starting its journey from the stationary position, then the value of u will be equal to 0, or we can say that the work done will be half mv squared, right, students? So it is the energy that is being possessed by the body by the virtue of its motion, right? So in that case, we name this work energy as kinetic energy, and the formula becomes half mv squared. Understood, students? So what is the formula for kinetic energy? The formula for kinetic energy is half mv squared, right, students? Okay. So what is m? M is the mass of the body and v is the velocity of the object. Right, students? M is the mass of the object and v is the velocity of the object. Understood, students? Right. Now let's do a numerical. Okay. So now suppose that an object of mass 15 kg. Okay. So mass is how much? Mass is 15 kg is moving with a uniform velocity of 4 meter per second. Right. So the velocity is what? It is 4 meter per second, and we need to find the kinetic energy. Okay. So we know that kinetic energy, this equals to half into mass into velocity. So we have written the mass, we have written the velocity. So just multiply it with half. Right, students? So this will cancel and this will give 2. So it will be 30 joules of energy. Understood, students? The kinetic energy will be 30 joules. Understood? So now let's proceed ahead. Here is a quiz for you. So, how can you define kinetic energy? Yes, students? Right. So, kinetic energy can be defined as energy possessed by anybody if by the virtue of its motion, right? Kinetic energy is the energy possessed by anybody by virtue of its motion, right, students? So what is the formula of kinetic energy, students? Yes, it is half mv squared. Okay, students, it is half mv squared. Right. So now we have completed our today's class. So now just go for recapitulation. So students, in our today's class, we have studied about energy. So now let's quickly answer a few questions, right? So what is energy, students? Yes, sir, the energy is the ability to do work. Understood, students? Yes. So what is the SI unit of energy, students? Yes, the SI unit of energy is joule. Okay. So now, how can we describe the work? Means how the work is being done. So the work is being done when the energy transforms from one form into another. Right, students? Yes. So what is kinetic energy, students? Yes. The kinetic energy is the energy possessed by the body by the virtue of its motion. Understood, students? The energy possessed by the body by the virtue of its motion is called as the kinetic energy. Right? So, where we can find kinetic energy, students? Okay, first of all, we saw this example, look, like a ball is moving, it is having what? It is having kinetic energy. Or we can say that somebody is running, right? So he is also having what? He is also having kinetic energy. Understood, students? Right. So now let's quickly move ahead to the homework section. So this is your homework section. This is an activity. What you need to do is take a large ball, place it on a heavy layer of sand, and damp the sand bed would be preferable. Okay, so you need to like wet the sand, and after that drop the ball from a height of around 25 centimeter and see the depression formed into it, right? Then repeat this activity with 50 centimeter, 1 meter, 1.5 meter height, and just note how much deeper it is making the depression. Okay, students? Right. Mark this depression and just see it what is the result coming to it. Okay, students? Right. You need to discuss and examine the results. So that's all for today, students. Thank you everyone for attending this class.